All right, we're in section 3.1 where we're going to identify pairs of lines and angles. So when we're looking at uh, line and plane relationships, especially when you have multiple lines or multiple planes, one of the things that we're going to look at are both per parallel skew lines and then also uh, parallel planes. So we should be pretty familiar with parallel lines. Parallel lines were two lines that do not intersect, but one of the things that we usually don't mention is that those two lines that don't intersect must be coplanar for them to be parallel. With skew lines, those two lines do not intersect either, but they're not coplanar, so they're not on the same plane. So that's something that we have to keep in mind when we're looking for those two things. Are they coplanar with each other? Are they not coplanar with each other? That's where we can make the difference between uh, parallel and skew lines. Parallel planes are planes that do not touch. So what we're going to look here is we have a diagram here, and what we have is all of the questions that we have here are with respect to line AF and also with point E. So um, we're going to use those points to kind of help us out. So the first thing is they want to find a line that's parallel to AF, the one that's green, and also contains point E. So the line that is parallel and fits all of those descriptions is going to be line EJ. All right, it's right here. Second one is a skew line that's to AF and also point E. In this case, it's going to be right here, so that's where line ED comes into play. It doesn't intersect AF, but it's also not on the same plane, so that's why we can say that. Uh, they want something that's perpendicular to AF, but also contains point E, so it would be this one right here. So it's going to be what, AE, and we were looking for a plane that is parallel to FGH, so that's that five-sided figure in the back, so that means it's going to be the five-sided figure in the front, so you just have to choose 3 points to make the plane, so we can just say it's plane A, B, C. Right, it does contain point E. We don't have to use point E to name it or anything. So same thing here. They want us to find a line that's parallel to MN. So if we look, MN's right there, but they also want us to use point J. So with that, it looks like it's going to be JL is our line. The skew line that they would like us to look at, that also has point J in it, but it's skewed to MN, and that would be JK right here. It's not intersecting, but it's now also not coplanar. So, and then they were looking for a perpendicular line to MN. It also contains point J. That would be JN. And then they want you to name a plane that contains J and appears to be parallel to M and O. So it's the triangle in the back, so it's going to be the triangle in the front, so plane JKL. All right, so we got two postulates to look at here. Postulate 13, the parallel postulate, states that if there is a line and a point not on the line, there is exactly one line through the point parallel to the given line. So we have this line L right here, and we have this point P. So what they're saying is that from that point P that's not on line L, there you can create a line that is parallel to line L and its touching point P. Anytime you see these little arrows, that establishes that those two lines are parallel, and it's a way that we can illustrate that. Um, Postulate 14, the perpendicular postulate, it's very similar to the parallel postulate. So if you, it says if there's a line and a point not on a line, there's exactly one line through the point that is perpendicular to the given line. So you have again point L, or line L, I'm sorry, point P, and not only could you find a parallel line, you can also find a perpendicular line. And like always, we can determine when something is perpendicular by having that right angle symbol there. All right, so here we have a diagram. First off, easy enough since we have uh, the two arrows there, we can determine that AB is parallel to CD. These little two vertical lines like that represent the symbol for parallel. The perpendicular lines, anytime they show us the right angle, which is right here, AB is perpendicular to AC. That upside down T represents perpendicular. But the question they ask here is AB perpendicular to BC. So they're saying AB is right here and BC is right here. All right. So right off the bat, it doesn't look like it. So the answer is no, but that's not the explanation that they're looking for. The explanation that they're looking for is comes from respect to the perpendicular postulate. So we can say because of the perpendicular postulate, there is exactly one line parallel to AB through point C, and that's AC. So we can say that because of the perpendicular postulate, there is exactly one line perpendicular to AB through point C, and that's AC. Okay. The question they ask here is, can you use the perpendicular postulate theorem to show that AC is perpendicular to CD? So AC is perpendicular to CD. It appears that it could be, but to show it that it's through that postulate, the answer is no. And the reason why the answer is no is since there's no right angle symbol, there's not enough info. Now, is it probably, but you could probably prove it using some other items. So that's what we can say about that. So next we have a transversal. A transversal is a line that intersects two or more coplanar lines at different points. So what we have here is line A and line B. The transversal in this case is line T. The reason why it's the transversal is because it's the line that connects more than one point. So that's what we can say about that. The reason why a transversal is important is we're going to dive into uh, different angle relationships for those respected transversals, and we'll be able to kind of get an idea of what we're looking at. So if we look here, we have, let's say we got 1, 2, 3, we got 4, 5, 6, 7, 8. So don't have them all written down. So these are all the angles here. The very first one is talking about corresponding angles. Corresponding angles are when you look at each respected line that's connected to the transversal, uh, the angle and the positioning on what they are with respect to the transversal makes it corresponding angles because they are in the quote unquote same position. So if you look at angle 2, that angle is in the top right, and so is also angle 6. So if you look here, if you put this in, that's top right, that's why they're corresponding angles. There are other ones like 1 and 5, those are corresponding. 3 and 7, 2 and 6, and 4 and 8. Okay. Alternating interior angles are where if you look how they're shaped in the transversal, they're inside, but they're also on opposite sides of the transversal, so that's why it's alternating interior angles, and that's what we could say that 4 and 5 are alternating interior angles. Alternating exterior angles are on the outside of the transversal and they're on opposite ends. So if you have 1 and 7, those are examples of alternating exterior angles. And we have other ones as well. We could say that 2 and 8 would also be considered uh, alternating exterior angle. The last type of angle relationship in this case would be consecutive interior angles. That's when they're on the same side um, of a transversal, but it's on the interior. So 3 and 5 are consecutive interior angles for that particular example. So I have a series of questions here they want us to answer using the diagram to the right. So right off the bat, they want us to identify all the pairs of corresponding angles. So I look here, top left, I know that angle 1 and angle 3 correspond. Bottom left, angle 5 and angle 7. Top right, angle 2 and angle 4. And bottom right, angle 6 and angle 8. So those are all the corresponding angles in this particular example. Looking at alternating interior angles, alternating interior, so it's inside. So I can say that 2 and 7, angle 2 and angle 7, and angle 6 and angle 3. Look over here, alternating exterior angles, so it's opposite out. So here and here, so we got angle 1 and angle 8, and angle 5 and angle 4. Finally, we got the pairs of consecutive interior angles. Consecutive interior angles are here and here and here and here. So we got angle 2 and angle 3 plus angle 6 and angle 7. So if we look below here, they want us to classify these. So since they're on the same side, they're inside the transversal. Those are consecutive interior angles. These two, 1 and 2, are on the outside and they're opposites of each other. Those are alternating exterior angles. And that is being able to identify pairs of lines and angles. Hope this helps. Until next time.